All right. So for the turning point, we're gonna need turning point. Let's let a turning point be q. In this case, we're gonna need x value. Okay, let's say turning point like this. Okay, we're gonna need a p value, which is value of x, and q value. How do we get that value? We're gonna use this formula to get a value of x being that p. Then after that, we're gonna find the value of q. How do we find the value of q? We use the value of x that we have determined and substitute into the original equation in order to get a corresponding y value, which is in this case is q. Okay, then what is b? B in this equation is going to be a coefficient of x, not x squared. The coefficient of x of a parabola is b, and the coefficient of x squared is a. So this is a and this is b, as indicated there, as you can see. Yes, so this is a and this is this is b and this is a. Okay, so b is 1 and a is 2 in this case. Okay, let's go and substitute here. So we're gonna have minus b is 1, 2 is a constant, and here you have 2. That means you have 1 over 4, minus 1 over 4 as your q. So your q is minus 1 over 4. Okay, where is that on the graph? We need to have that on the graph. Where is that on the graph? This is a quarter of 1, so it's something that can be here. Okay, but it's gonna go down because our y-intercept is on the negative side, so it's gonna go down. I think y value is gonna be around, but it's gonna be greater than 3. It's gonna be around here. Let's go and determine y value. Okay, our equation is given by 2x squared plus x minus 3, but our x in this case that we're going to substitute which is p in this case, is minus 1 over 4 over 4. This is to the power 2 because to the power 2 is here, plus the x value, which is minus 1 over 4 minus 3. All right, you can take this into your calculator and determine if what value it would be, but for simplicity's sake, let's assume that we're gonna get a value being minus 5. For simplicity purpose, I'm not sure what the answer would be here, but for simplicity purpose, let's assume that the answer would be minus 5. All right, so that would mean that on our graph, we're gonna have minus 5 here as our turning point. So we have minus 1 over 4 here corresponding with minus 5. So our graph has to turn here. Okay, so it has to cut y-intercept at minus 3 and x-intercept on the positive sides at 1, as you can see, and on this side it has to cut y-intercept or x line on negative 3 over 2. All right, as indicated there. Okay, so that is our graph. We can name it f of x. If it was f of x, we can name this g of x if it was g of x. Okay, we can interpret from here. There are many things that we can interpret from here. There are many questions that can be asked from here. Okay, the question can be this can be a and this can be b. this being C, this being D, and this being E. Okay, so there are many questions that can be asked here. The first one, they can ask you to determine the coordinate of B. How do you determine the coordinate of B? The question that we have to ask ourselves, what is B in the graph? What is B? Because we need to know what is B in the graph before we can determine what is the value of B, okay? So the B is the intersection of the two graphs, okay? Is the intersection of the two graphs, meaning if this is f of x, this is g of x, where they intersect, those graphs are sharing exactly the same values where they meet, or where they intersect each other. They're sharing exactly the same value. What does that mean? It means that they are equal. If they are equal, we can simply say f of x at that place is equal to g of x. And what is the equation of f of x? We said is given by 2x squared plus x minus 3. What is the equation of g of x? It was given by 2x plus 3. So we can simply, for determining the value here, we can simply determine x, meaning we're gonna cross this to that side, or we can do whatever, or arrange these terms to this side. You see, we might end up having x squared to the power, x 2x squared plus or minus, because when this comes this side, this is positive, it's gonna cancel 1x, and we'll be left with 1x, which is negative, because when that comes to this side, it's going to be negative, and this comes this side is going to be negative. We already have a negative constant term here, so minus 3 minus 3 is minus 6, which is equal to 0. So from here you can determine values of x, but at the end of the day your value is going to be this one, and determine the value of y, substituting by the value of x that we're going to be getting here in any of these equations. Is either going to use g of x or f of x, but you're going to get the same value. So you're going to get what the values of b are if you are doing that, right? But for simplicity purpose, we're not going to go into algebra for now, right? But I'm just illustrating the point, the mechanics of how to determine that value. The other way of determining the value of b, the b in this case is x-intercept of both graph, meaning you can determine x-intercept of this graph because it's touching x at b. You can determine b, and your x-intercept is going to be exactly the coordinate of b. Or you can determine the x-intercept of this graph, which is parabola in this case. Your x-intercept again is going to give you the same value as we did previously. I think that makes sense. Okay. If they are asking you the value of a, the coordinate of a, the point a, to determine point a, but you are given an equation, what does that mean? What is a? That is the first question that we have to ask ourselves before determining anything. A is a y, is a x-intercept of which graph? Of f of x. Where is the equation of f of x? Equation of f of x, it was given here as this one, as 2x squared plus x minus 3, meaning we need to determine x-intercepts of this graph, and the positive value would be a, because a is on the positive side of the graph. So that value that we're getting out of the x-intercept of this graph would be exactly the value of a. As you can see, I think that makes sense, but we're still gonna make a multiple example and you solve previous questions together. I think it will make sense as we go along if it didn't for now. Okay. If they ask you to determine the coordinate of D, what is D in the graph? The D is obvious, the turning point of which graph of f of x. Where's the equation of f of x? Is given, it's here. So you need to go straight to the equation of f of x in this case and determine the turning point. How to determine the turning point? You do the same thing that we did here. You have this equation, right, which is x equals to minus b over 2a, and you substitute your b, you substitute your a, and you get to the value of x in the turning point, and you take the value of x to get the corresponding y value. You take it to the original equation, which is this one, you substitute and get the value of the turning point being y in this case. All right, that's how simple it is. What is this? If they ask you to determine c, what is c in the graph? It's where the graph of g is cutting y-axis. What do we call that? It's y-intercept. Okay, where's g? G is here. Which value or which term is standing or is for y-intercept in this case? It's just that three constant term. So it means that the coordinate of c in this case would be 0 is to 3, and you got your mark, you go. Okay, if they are asking about the coordinate of e, how do we determine E in this case? Where is E? That is our first starting point. Where is E? E is in the E is on the parabola, and it's what? It's the y-intercept, because it's where the graph cuts y-axis. So it's a y-intercept. So let's go to the equation. Here is the equation of f of x. That means this is the value that we're looking for. This is our turning point. This is our y-intercept because it's a constant term. It's the c value, which is the y-intercept in this case. So our coordinate, if minus 3 is not given there, it's just e. We're going to simply say it's 0 is to minus 3 because here it is, you see. And you will be done by that at 52, right? 52.